Alright, 3-8, we're talking about oblique asymptotes. Now, oblique asymptotes, what are they? Well, first of all, another name for oblique asymptote is slant asymptote, and that's exactly what it means. As you can see on this example with the graph from the right, okay, the slant asymptote is an asymptote that's slanted. It's not vertical, it's not horizontal, okay, it's slanted, okay. So the question is, how do we find them? Alright. So then here what we've got is we want to consider a rational function whose denominator is of degree 1 or greater if the degree of the numerator is exactly 1 more than the degree of the denominator. So the degree of the numerator exactly 1 more than the degree of the denominator. So if the degree of the numerator is greater by 1, okay, then the graph of the function has a slant or oblique asymptote. Alright, so this is the graph that's graphed off to the side, and notice the numerator is 2, the denominator, the power is 1. This one is exactly 1 greater. Alright, so if it's 2 and 1, 3 and 2, 4 and 3, 5 and 4, and so on, you will have an oblique asymptote. So the top has to be exactly 1 greater. Exactly 1 greater. Alright, so how do we find it? So to find the equation of a slant asymptote, you use long division. And so by dividing x plus 1 into x squared minus x, okay, we have this. They divided it out. And so this is the quotient plus this remainder. And so this part of it is the slant asymptote. Okay, and the reason why this part of it is the slant asymptote is because the remainder part right here, as it increases or decreases without bound, the remainder term approaches 0. In other words, that makes this bottom number really big, and then so that the remainder approaches 0. Alright? So that's why this portion is your slant asymptote, right? So not the remainder. Okay? Alright. Let's see. So again, the graph of f approaches the line y equals x minus 2. Alright, so there you go. Alright, so how do we actually do one of these problems? So we want to find the slant asymptote for this particular function. So what do I need to do? I need to divide this out. Now, in this case, since I have x minus 1, this form, I can actually use synthetic division instead of long division, and that may save me a little bit of time because it's a little faster. And so when I'm doing this, minus 1, we'll change this to a 1 right here. I'm going to put the coefficients of the top in there, which are 1, negative 1, and negative 2. And we're going to just divide this thing out. This drops to here. 1 times 1 is 1. That subtracts out to 0. This will be times 0, which is 0. And then this will be minus 2. And so, okay, when we look at this now, this thing, the way this thing divides out, okay, so it's going to divide out into this, which is just an x, right? Okay, so this thing's just going to divide out into an x. And so when I'm looking at this quotient part of it here, so f of x equals, all right, so this would be x plus no constant, and then there's your remainder. So that would be x, and then minus, right, 2 over x minus 1. Alright, so there's our remainder. Okay? And so when I divide it out, that's what this function is going to be. Now, what's the slant asymptote here? Well, the slant asymptote is this portion, alright, of the function once you divide it out. So it's going to be y equals x. Alright, so y equals x is going to be your slant asymptote. So there we go. Alright, let's try another one. Okay, so for this one, we cannot use, well, first of all, you got to double check this. Powers 3, powers 2, the numerator is 1 greater. It does have a slant asymptote. Now we cannot use synthetic division on this one because remember the synthetic division algorithm only works for x term, right? So once we get to x squareds and things like that, not going to work. Okay, but I still can divide it out. I can go x squared plus 0x, remember I need that placeholder there, plus 4. That's being divided into x to the third plus 0x squared plus 0x plus 0. Okay, you might be asking yourself, is that really all that necessary? The answer is yes, because remember when you're dividing out with long division, you need to have a placeholder for every power for it to divide out and work. Alright, so again I want to make the leading terms match. So to do that, then I will just multiply this times x. Alright, so this is going to be x times x squared, which is x to the third, and then of course drops in as negative x to the third, and then they'll cancel out just like I want. So then here I've got x times 0x, so that's going to be minus, right, 0x squared. And so here I've got x times 4, and then that's going to change to minus 4x. Alright, let's see what we got here. Gone, gone, and this will be negative 4x, and plus 0 drops down. I need the placeholder. And so really, there's no more division necessary here. That is your remainder, right? Because there's nothing else really to divide out in this thing. And so the division here is going to give me x minus, because that's a negative, 4x over x squared plus 4. So that's your remainder. Okay. Now, I can rewrite the function as f of x equals x minus 4x over x squared plus 4. Alright? Now, remember, as x approaches infinity here, right, it's really large, then we can say that this portion is going to be your slant asymptote. So y equals to x is going to be my slant asymptote here. Okay? Alright. Now, suppose we wanted to just make sure that that was correct. Well, how's the best way to double check that? But by graphing. So let's go back into our Desmos and let's just put this graph on here and make sure everything is good to go on this thing. So I'm going to go y equals, I'll need my fraction. I'm going to go x to the third power on the top. And on the bottom, we're going to go x squared plus 4. Alright, so once again, when we look at this, okay, we can see that my slant asymptote here is going to be y equals x. And so y equals x is easy to follow on this graph because it's just going to be those corners every time. And the further you go out, the closer and closer to that corner without actually ever getting there it gets. Everybody see that? So y equals x is going to be your asymptote here. Okay. Alright, so there we go. So we can trust the system. Alright. One more to take a look at here. First of all, we need to divide this thing out. Well, first of all, we need to check and see, does it have a slant asymptote? 3, 2, this one is one bigger, it does. Okay, can we use synthetic division? No, we cannot, because it's more than just x to the first power. And so I'm going to have to divide it out long ways by hand. 2x squared plus 0x. Remember, dividing out, you need all of your descending orders of the power for placeholder purposes. And I'm going to divide that into x to the third plus 2x squared plus 4. Okay. again, I want the leading coefficients to match here. And so I need to make sure that this matches up. Well, the only way I'm going to turn 2x squared into x to the third is I've got to turn this 2 into a 1, and I've got to turn this squared into a third power. Only way I can accomplish both of those is to multiply by 1/2 x. And when I do, look what happens. Okay, that's going to be x to the third, minus when it drops in, by the way, but that's what we want anyways. Alright, so positive times a positive, well, that's 0 is not positive or negative, and so when it drops in, it's going to be minus 0x squared. And so from here, that's going to be positive, so that'll be a minus 1/2 x. And one thing that I forgot to do was put in a placeholder 0x. So I'm going to make that 0x now, and then I'm going to change that to a 4. And so that's going to be minus 1/2 x. And so again, these powers should line up correctly. And if they don't, like what I was looking at that 4, that should be a sign that you forgot to do something. And typically with synthetic division, it's going to be put in a placeholder or one of the powers. Alright, now we can subtract it on off. And as we do, that's gone. That's going to be 2x squared minus 1/2 x, and a plus 4 goes here. Okay, good shape again. And so now, next thing that we were going to do here is we're going to try to match it up again. So how do I turn 2x squared into 2x squared? Plus 1. And it'll drop in as a minus x squared. Do I have an x term? No, I don't. It's minus 0x. But I do have a 1 term, and 1 times 1 is 1, so it'll change to minus 1. Alright, gone there. That's going to end up being negative 1/2 x plus 3. Alright, and that is as far as we can divide it out, so that's my remainder, so it's negative. So that's going to be, now this is tricky here. If you think about this for a minute, make sure we get this right. So it'll be minus, and on the top, of course, we're going to have 1/2 x. Now don't forget, okay, since I pulled that minus out here, that negative, it's got to change the sign of both of the terms. That's one thing that sometimes is forgotten with these fractions, negative fractions. So that's actually going to be a minus 3. So plus 3 down here is going to be minus 3 when it drops in, just because of that, pulling out that negative. And so on the bottom, then we'll have the original denominator, which is going to be 2x squared plus 1. Okay, so I can rewrite this now. F of x, after we divide it out, is going to look like this. Oops. Equals 1/2 x plus 1 minus this remainder, 1/2 x minus 3 over 2x squared plus 1. Alright, now which part of this is the slant asymptote? The part before the remainder. So my slant asymptote is actually y equals 1/2 x plus 1. Alright, so there we go. Okay, good to go.